Okay, so this is some chapter 3 stuff. The graphical one was chapter 3, analyzing also chapter 3, just different types of problems. Here, down here, all the good stuff. I'm not going to go into any of that. I will tell you that I didn't draw this chart on the graphical analysis video. It's very helpful, even more so I think on this lesson. So this is the same thing we had been doing in class. It just helps you organize the relationship between f, f prime, and f double prime. Okay, so you're going to do one on your own. Let's look at two together. So we have this function, and we want to know about concavity. We want to know the second derivative. So first things first, find the first derivative. So that would be 15x to the fourth minus 60x squared. And we take the derivative again. Okay, so that would be 60x cubed minus 120x. Now I want to know where the second derivative is equal to 0. So factor out of 60, factor out an x. You are left with x squared minus 2. And when you set each thing equal to 0 for your possible points of inflection, you get x equals 0, and then here I get x squared equals 2. Now if that was negative 2, by the way, I would stop and be done with this part. But here I have to, so actually I can square root 2. It's not pretty, but it's possible. You cannot square root negatives, but you can square root of 2. So I have 3 possible points of inflection. So what you want to do from here is label them out on a sign chart. Okay, and we want to know concave up. So we want to know where is f double prime positive. So down here would be f double prime, up here would be f. So I'd take a number to the left of negative 2, and I would plug this into that second derivative. So I would get a negative number, okay, times a positive number. So a negative, that's concave down. If I take something like negative 1, though, I get a negative times a negative, which is a positive. If I take something like 1, I get a positive times a negative. If I take a bigger number, they'll both be positive. Okay, so concave up, that would be right here and right here. So your answer would be B. Okay, you can skip 3. It's not a bad problem. It's just a little gross to be doing on your own. So let's skip now to number 4. Point of inflection. We know from our chart and just from learning that point of inflection is when f double prime changes signs. So here I have f double prime. Let's set it equal to 0. Now, when I do this, I already have my answer staring at me because this is factored. So I have x equals 0, x equals negative 1, and x equals 2. These are, again, possible points of inflection. Now, last time they all end up being points of inflection. Here, though, something else is going to happen. And you list these in order, and then down here would be f double prime, up here would be f. Okay, if I take a number to, like, say, a negative number times this thing squared is always going to be positive. So negative times a negative, positive, concave up. If I take a fraction, though, that's going to be negative, but this is going to be positive. If I take something like 1, positive. And if I take something bigger than 2, also positive. So there was no change around 2. So that means that 2 is not a point of inflection. 0 is, and negative 1 is. So my answer is C. The reason why 2 ended up not being a point of inflection was because what gave me 2 was taken to an even power. Okay, let's look at, I'm not going to do 5, I'm just going to start it for you. Just making sure because there's a little trick to 5. So we just need to find the first derivative here. We don't really need to go any further than that. We need to set the first derivative equal to 0, so factor out a 2x. You're left with 2x squared plus 1. And when you set 2x equal to 0, you get x equal to 0. These are not points of inflection. This is first derivative we're talking about here, so these are critical numbers. But over here, you have 2x squared equals negative 1. Divide by 2, get negative half. And as soon as you put a square root around a negative, stop. That's imaginary. So you only have one critical number. So I'm going to leave you to do that one by yourself. You'll do 6 by yourself. You do get to skip 7 and 8. This is a pretty lengthy packet, so there's a few I skipped here just for length purposes. You can skip 10 and 11. You'll do 12 on your own though. You can skip 13, A, and C. I do want you to try to do 13. I know that it's a trig problem, but I want you to try to do 13B by yourself. 14, I want you to do part A by itself, but you can skip part B. 15, I want you to try to do all of that one. And then 16, we're going to do together. Okay, so you're given H prime. Okay, and they give us this little h of 4 equals -3. By the way, that just, oops, going too fast here. That just means this point is on the curve. So we're trying to find all the values of x where h has a horizontal tangent. That is where the derivative equals 0. This is a little different than critical numbers. Critical numbers are where the first derivative was 0 or undefined. We're just doing 0 here. So we want to know where this thing is equal to 0. Okay, this is, we don't take the derivative. This is already the derivative. All right, so that really just means I want to know where the top is 0, because if the bottom was 0, that would be undefined. So I ended up getting x squared equals 2. So x equals plus minus radical 2, and we'll just say I kept that in its own space. So now I need to do a sign chart. Now when you do the sign chart, you do need to include any other critical numbers. We're not going to like explain them, but we need to put 0 here. 0 is what causes my first derivative to be undefined. Okay, so h prime, h, and you need to test all of this. Okay, so we need to test into here. Okay, numbers to the left of -2, that's going to give me a positive divided by a negative. So h is decreasing. Something like -1. That's going to give you negative divided by negative, positive. And I'm not going to work out the rest of this, but it does something like that. So now we need to say, okay, at these two values, plus minus -2, what's happening? H has a relative, you can just look right at the picture, decreasing and increasing. A relative min at x equals √2 and x equals -√2 because h prime changes signs. What does it change from? From negative to positive. All right, let's look at part B. Where is h concave up? We need to do the second derivative here. So this means we need to do quotient rule. Derivative of the top times the bottom minus the top times derivative of the bottom over the bottom squared. So this becomes 2x squared minus x squared plus 2. You got to distribute that negative, or x squared plus 2 over x squared. All right, now in thinking about concavity and possible points of inflection, you got to think, what makes the top 0? What makes the bottom 0? All right, the only one I get is x equals 0. If you try to make the top equal to 0, you get an imaginary number. So my only possible point of inflection is 0. All right, and if I go ahead, hopefully you're not writing as big as I am. If I go ahead and make a chart here, if I take a number that is less than 0, I get a positive result, concave up. If I get a number greater than 0, that's also positive, concave up. So h is actually concave up, not everywhere. From -infinity to 0 and from 0 to infinity. We had to skip over 0. Why? Because h double prime is positive. At 0, h double prime is 0, so that's why I can't include it. Okay, write an equation of the tangent line. Well, remember, we need a point, and they flat out gave us that. 4, -3, and we need a slope. Our slope is going to come from h prime. Okay, h prime of 4. So that's going to be 4 squared minus 2 over 4. When you crunch those numbers, you get 7/2. So the tangent line, I think, was the easiest part of this problem. So I went through that pretty fast. You may want to rewind and kind of go back through the steps. All right. So you need to do all the ones that I didn't do except for the ones I told you to skip.